The largest space operations activity in the Department of Defense is the Air Force Satellite Control Facility located at Sunnyvale Air Force Station in California. This unique facility has the awesome responsibility of tracking, commanding, controlling, and processing orbital data of military spacecraft orbiting in space today. The Satellite Control Facility, or SCF, is a major contingent of the Navy for space operations located at Space Division Headquarters in Los Angeles. In order to perform its mission, the SCF has developed a resource of trained personnel and sound operating procedures that exploit the full capabilities of each satellite while ensuring its continued health and long life in orbit. The primary responsibility of the SCF is to operate and maintain a common user spacecraft support network for the Department of Defense. This network consists of the necessary resources to meet the round-the-clock, year-round mission support requirements of its many users. Through its worldwide network of satellite tracking and commanding stations, the SCF can support equatorial launches from the Eastern Space and Missile Center at Cape Canaveral Air Force Station in Florida, polar launches from the Western Space and Missile Center at Vandenberg Air Force Base in California, low-altitude satellites during virtually every one of their daily Earth revolutions, and other satellites in a wide variety of orbits. In addition to the resources located at Sunnyvale, remote tracking stations, or RTSs, are located at far-flung locations throughout the world and at Vandenberg Air Force Base. In addition to its tracking role, the Vandenberg facility is used to support launches and ballistic missile activity at the nearby Western Space and Missile Center. Similarly, a remote tracking station is located at Manchester in New Hampshire, and one of its functions is to provide on-the-pad pre-flight checkout of launches from the Eastern Space and Missile Center. A tracking station is located at Thule Air Force Base in Greenland and is used primarily to support satellites in polar orbit. Thule is the northernmost station and can provide on-orbit support of all polar orbiting satellites on each revolution. Another RTS is located in the Indian Ocean on the island of Mahi in the Seychelles. The Indian Ocean Station is the prime SCF station for communicating with the National Space Transportation System, the Space Shuttle. The Indian Ocean Station also provides on-orbit support and monitors orbit injection for almost all satellite launches. Other stations are located at Oak Hangar near London, England, on Anderson Air Force Base on the island of Guam, and in Hawaii at Kena Point Air Force Station on the island of Oahu. In addition to normal satellite support, the Hawaii station and the Guam station are used to assist with ballistic missile testing in addition to on-orbit and recovery operations. Except for the Oak Hangar facility, each tracking station is commanded by a military officer who also functions as the administrative contracts officer in monitoring the performance of the operations and maintenance activities, as well as those of the integrating contractor and all other contracts for the station. The Oak Hangar facility is owned by the United Kingdom and leased to SCF for various specific operational missions. The SCF and the 7 remote tracking stations constitute the largest and busiest satellite control facility in the tracking stations are continuously supporting satellites. 3 of these stations are dual stations. That is, they can support 2 satellites at the same time, one with each side of the station. To distinguish between the 2 sets of equipment, one side is designated A, and the other side is designated B. Currently, the network has the capability to support 12 orbiting vehicles in 12 different configurations at any given time. An individual tracking station performs a number of functions during its contact with a satellite. It gathers raw data from an orbit and transmits it directly to Sunnyvale, or processes the information by computers beforehand. The data transmitted includes payload information, as well as information regarding the health and status of the satellite. Conversely, the RTS can transmit commands to the spacecraft, which are actuated immediately or stored in onboard processors for later execution. Satellite health and payload data are relayed from the RTSs to Sunnyvale via an extensive communications network, which includes both wideband satellite links and narrowband landing circuits. Most stations have access to Defense Communications Agency, or DCA, Earth terminals, which transmit the digital downlink data via Defense Satellite Communication System spacecraft, which are in geosynchronous orbits over the East Pacific and West Pacific Ocean areas, to similar Earth terminals at the Satellite Test Center in Sunnyvale. Wideband service between Vandenberg and Sunnyvale and Thule and Sunnyvale is leased from commercial communication carriers who employ similar satellite links. Whether military or commercial, these wideband links are fully duplex and are also used to relay the digital uplink data from the individual RTSs. Outbound uplink data is transmitted from Sunnyvale to each RTS in 5 channels at a combined rate of 192,000 bits per second. Inbound downlink data is received from the RTSs at Sunnyvale in 7 channels at a combined rate of 1.54 million bits per second. The SCF network supports an inventory of approximately 45 satellites with a variety of missions. These missions include navigation, weather, communications, and surveillance. Over 250 contacts are made every day with the satellites on orbit. These contacts are managed primarily by 10 mission control centers, each having responsibility for various satellite programs. Most of the control centers are operating continuously, either planning for or actually conducting satellite support operations. Mission control centers are fed data gathered by the tracking stations by a buffer complex composed of 10 Varian 75 computers. These data buffers are also used to carry on duplex digital data communications with the RTSs over 2,400 bit per second narrowband circuits. UNIVAC 1230 computers are used by the RTS to record and relay data to the satellite control facility. Data transmission over the entire network is managed by a data systems control station known as ASIS. ASIS is used to channel data coming in from an RTS to a previously scheduled buffer computer and to distribute this data to the mission control centers supporting that function. The primary job of ASIS is to monitor the health and status of network data circuits while maintaining voice communication with all of the RTSs. The command post of the network is the SCF Operations Center. From this vantage point, the facility commander and his staff can remain fully apprised of the situational aspects of all spacecraft on orbit, as well as the condition of the entire network itself. A Space Defense Operations Center terminal is also in operation at this facility. At a daily staff meeting, the commander and program managers are brought up to date on all aspects of planning and managing the spacecraft assigned. Workload control and status management of the ground tracking network is continuously monitored in the network's data center. The vehicles supported by the SCF may be divided into 5 general categories: low altitude, medium altitude, high altitude, ballistics, and ascent only. Low-altitude satellites are characterized by polar orbits, orbital altitudes of approximately 100 to 200 miles, short lifetime, and short pass durations of from 2.5 to 10 minutes over a tracking station. These satellites, the most time dynamic of all those supported by the SCF, require relatively frequent transmissions of command messages every revolution, and require support from an average of 1.5 tracking stations for each Earth revolution. Medium altitude satellites generally have an orbital inclination near 90 degrees, an altitude between 200 and 1,000 nautical miles, a planned 1 year or longer support life, and a pass duration of 10 to 20 minutes. Average support for these satellites is 1 station contact every 2 revolutions. The high-altitude satellites have low-inclination equatorial orbits, altitudes in excess of 10,000 nautical miles, and long support lives, sometimes years. Pass durations can vary from an hour or less to continuous for synchronous vehicles. These satellites are generally not serviced for the entire period they are in range of a tracking station. Except when position-fixed or time-fixed support requirements require more precision, extreme latitude and support scheduling is possible. Support periods vary from 5 minutes every 2 days to 16 hours per day for these satellites. The category of ballistic missiles includes both ballistic missiles and suborbital test vehicles that normally are launched from the Western Space and Missile Center, Vandenberg, and are supported for short periods by the appropriate tracking stations. For these satellites, tracking and telemetry data are recorded during ascent and mid-course phases. Total support time ranges between 10 and 30 minutes per flight. Certain non-SCF orbital vehicles are also supported during launch and ascent, or during ascent only. Support may vary between 10 minutes and 10 hours, depending on the vehicle's orbital characteristics and the support requirements levied on the SCF. Range control is the nerve center for range operations. This computerized graphic plot, called the acquisition chart, is put together on a continuous basis to provide a record of the time a particular satellite will be passing over a given tracking station and how long it will remain in view. This information is relayed electronically on a daily basis to the tracking stations with instructions telling them which satellite to track at a particular time. Each remote station furnishes the ground space link with the satellite, enabling the mission controllers at the SCF to command the vehicle, control it, and direct the readout of telemetry data. The remote stations are involved in 3 basic support functions: acquisition and tracking, commanding, and telemetry reception and relay. At the station, the telemetry, tracking, and command antenna must acquire the signals transmitted by the satellite. To do this, the antenna must be pointed at the satellite as it appears over the horizon, and then automatically track it as it passes over the station. Before the tracking begins, the stations receive updated ephemeris data from the SCF, representing the satellite's expected path. The moment the satellite clears the horizon and is acquired, the SCF is supplied with new satellite position information. Both angular and range data are used to update predicted orbital parameters and ephemerides, representing satellite location in space. Depending on the situation and in response to the satellite owner, the SCF directs the responsible remote station to transmit a variety of commands to the spacecraft. These commands can be executed immediately to accomplish a satellite function, or can be stored for later use through the satellite onboard processors. In the more complex satellites, these stored program commands can turn functions on and off and perform complex mechanical and electrical tasks for several Earth revolutions before being reloaded. Telemetry received by the tracking stations is recorded at the site and immediately transmitted to SCF mission controllers via the narrowband or wideband communication links to ACES and the buffer computers. Information forwarded includes data on the health and status of the satellite, as well as data collected by the satellite's sensors. Satellite performance analysis is performed primarily within the various mission control centers. payload data is relayed to user agencies. The Satellite Control Facility has a highly developed capability to provide emergency support to satellites which degrade or experience potentially catastrophic failures while on orbit. When the need for this support occurs, the responsible mission control team takes action to put the spacecraft in as safe a condition as possible. The team then initiates analysis of the problem by combining their detailed knowledge of the satellite with current telemetry data to isolate the cause of the failure and take corrective action. During the past 20 years, this process has resulted in the return to full service of a large number of satellites, thus restoring their capabilities within a minimum time frame and postponing or avoiding the need for the costly launch of a replacement. Some communications and navigation satellites require extensive measurement, testing, analysis, and calibration of signals they transmit while on orbit. This work is accomplished at the SCF radiometric testing facility at Camp Parks. Camp Parks is basically a two-sided facility. One side concentrates primarily on SHF and L-band operations, while the other side is devoted to VHF, UHF assignments. Personnel at the SCF are constantly searching for new and better ways to use their present software programs and equipment. A software development facility has been provided with access to all of the telemetry ground stations. Without interfering with the operational data system, the facility can be used to develop and check out new computer programs and equipment, ensuring use of the latest techniques and equipment for daily support of telemetry systems. The SCF force is composed of an integrated team of over 3,500 Air Force, contractor, and civilian personnel processing the necessary space and ground-related disciplines to support this demanding technology. The SCF personnel team is an unmatched resource with 20-year know-how and a record of preparation, on-orbit support, and mission evaluation performed in a professional and virtually flawless manner. The Air Force Satellite Control Facility is entering a period of time in which major changes to current operational methodology and capabilities will occur. These changes will provide better network survivability, modernized systems, and new program support capabilities. Within the next 5 years, space operations will be enhanced by the acquisition of the Consolidated Space Operations Center, or CSOC. CSOC will provide an expanded capability to meet continued growth of space use and the increasing number of satellites. The second portion of CSOC is the Shuttle Operations and Planning Center, which will be used to command and control all DoD space shuttle missions from launch through orbiter return. The remote tracking stations will be modernized with much more efficient command and control equipment that will reduce or eliminate labor-intensive tasks, which in turn will reduce the number of operating personnel. In addition, a new data system will make available new centralized command and control of the entire network, yielding more efficient use of existing resources. Specifically, all aspects of resource scheduling, switching, and routing will be under computer control. As the space capability of the Department of Defense continues to grow and become more complex, the more the SCF will be tasked to provide the equipment and trained personnel to meet the opportunities that such an expansion will require. It is to this specific challenge that the SCF has been dedicated and to which it is geared to respond. The Air Force Satellite Control Facility is ready now.